Welcome everyone. This is the first of our little lunch talk series where we're going to tell you a little bit about the CNMS, the Center for Nanophase Material Sciences, and how to get access to CNMS. Some of you already have worked with us in the past, and it's great to get you back. You know, this is not a screen. We're open for business, so we're doing science, even in these hard times. So the purpose of this is to kind of go over and showcase how easy it is to get access to our facilities, what kind of work we can do working with individuals and companies, and some of the ways and the mechanisms that this can be achieved. I'll be joined here by my colleagues, Ilya Ivanov, Brad Lokitz, our CNMS director, Karen Moore, and our IP specialist, Jennifer Carpenter, who all will go through little pieces of these important questions that I'm sure you have. So with that, I'll pass it over to Ilya with some other welcoming remarks.
Thank you, Alex. Let's see if I have live on me right now. Brad, do I have? There we go. Hello, everyone. Thank you, Alex, for introduction. So my name is Ilya Ivanov. I'm Research and Development Scientist at CNMS. I'd like to greet participants of this seminar. You're here because you want to learn more about what we can do together. And it's great. It's the first important step towards starting collaboration. You are interested, this is very important. The CNMS has tremendous research resources, which you're probably familiar with by looking just at our website, but which are not only represented by unique pieces of equipment, and we have quite a few of different pieces of equipment, as you can see on the website, but more importantly, by expertise of scientists who work here. Scientists with very diverse training and experience. Scientists who are capable to approach complex scientific problem and organize research team to solve it. This is very important. This research powerhouse effectively is open to everyone who has interest in scientific problem solving. Our resources can play an important role for businesses, and that's the reason why we're here and we're setting up this small series to discuss how business, small or large, could take advantage of this tremendous scientific capabilities. We oftentimes don't have bandwidth to work on ideas which could lead to breakthroughs or revolutionary products in the next 10 years, or the ideas that can give a competitive edge to the existing products. That's where you realize that you need help, and that's where we can help you. I strongly encourage you to reach out to CNMS industry liaisons, myself and Alex Bedaninov, to schedule online discussion of your particular idea that may we can actually organize a virtual tour of CNMS research facilities as well. So we can go in much more details of your particular interest in the future. And we'll post our contact information in the chat box later. And we'll forward our email addresses to all the participants of this seminar. Thank you. And I'd like to pass microphone to Karen.
Okay, thank you, Ilya. Thank you, Ilya. I'm going to share my screen because I have a presentation. Can you see it?
Yes.
Good. Okay. So thank you, Ilya and Alex, for doing a great job being our industrial liaisons. The major purpose of this is, of course, to inform potential industrial users of the capabilities at CNMS. But it's also to encourage industrial users to take advantage of the fact that we're here. We want you to collaborate, to integrate with some of the work that we're doing at the CNMS. We are highly focused on science, but we have capabilities that really can help you understand any number of fundamental questions that you might need to address. We have the tools, and as Ilya said, we have the staff with the expertise. So this is the main purpose of this seminar, this lunchtime seminar. So thank you for joining us, and let's see where we can go with this. So the CNMS, some of you have been here before, some of you may not have been here before. It's located at Oak Ridge National Laboratory, of course, but it's also joined to the spallation neutron source. So this is actually one of our strengths in that if you need to use neutron scattering capabilities, and you can access both of those facilities. We also, of course, have the Oak Ridge Leadership Computing Facility. Right now, we have Summit, which is the fastest computer in the world. Actually may have fallen to second fastest, but we'll leave that where it is. But all these user facilities are integrated in a way that allows you to access them, whether you come through the CNMS or whether you go through these other facilities. So, of course, the ALSUF helps us with a lot of our theory work, a lot of our simulations, helps us interpret data. So it's a very strong core of user facilities that's available to industry as well as other users. In FY19, which is the latest I have a full palette of data for, we had over 650 users. Now, this includes industry, although our industry participation is low, so we're seeking to increase that by encouraging you to take advantage of the fact that we're here. Our primary output, and I'm going to go into a little detail about this in the next slide, but our primary output is publications. All right, we are an Office of Science National Laboratory. That is our primary output, but that doesn't mean that we don't do different kinds of work, that we're not very interested in IP. So those questions will be answered later by Brad, by Ilya, by Jennifer, and by Alex. So we have invested very heavily lately in a lot of new cutting-edge tools that you may not find anywhere else in the world in some cases. We have instruments to support QIS, Quantum Information Science. We have some of the best imaging capabilities in the world, and that ranges from very, very nice scanning electron microscopes, which a lot of people make use of, but also very unique capabilities all the way at the top end of scanning transmission electron microscopy. So it's a very complete and fully functioning facility for imaging that has staff expertise, again, that you won't find anywhere else. We also have very nice facilities for nanofabrication. We have a clean room where many of our tools are located, so I'll talk a little bit about that later too. Note that we have both fall and spring proposal calls. Brad will talk about this a little bit more. We have an upcoming spring call. This is why we're actually scheduling this industrial seminar, to encourage you that if you're interested to think about submitting a proposal in the spring. So a quick overview. It's a nice picture of the CNMS. I have lots of lists of instruments that I'm not going to read thoroughly, but I wanted to point out two primary ways that industry, primarily, since that's who we're talking to, can access the capabilities that you see listed here at the CNMS. So of course we have the non-proprietary research route. Non-proprietary research requires submitting a proposal. It is free, which is very nice, but you have to be able to publish the results. So free means we have to get something out of it, right? And that is scholarly output, and that is one of the things that drives our facility. But there's another route that we don't have as many users, but we do have some very focused industrial projects that come to our lab to conduct proprietary research using tools, again, that you wouldn't have anywhere else, and they pay an hourly fee for both the instrument and the staff time. These results do not have to be published. It's proprietary. We can sign an NDA, and in this way you can conduct proprietary research, whether it's imaging, whether it's collecting data on in the clean room, whether it's performing simulations. All of these things, when they're considered proprietary, you get all the data back to you. We don't talk about it, we don't do anything about it. But industry tends to like to come in this way because they don't want to necessarily talk about some of their proprietary methods or their proprietary materials. So, but I think that it's very important to recognize that a lot of the work that we do is proprietary in nature. So here is a situation where we like to encourage our potential industrial users or partners to go onto our website and look at all these different capabilities that we have. Again, we have a lot of imaging capabilities that you may not think of when you think of imaging. I know a lot of people think of the more standard capabilities, but scanning probes and the atom probe are things that could provide information that you may not be able to get any other way. And those are capabilities that we have. Again, our nanofab, but I also want to talk a little about the combination or the integration, I should say, of theory with a lot of what we do, and more recently, the artificial intelligence and machine learning methods that we're putting in place to help make our processes, our data acquisition, and our instrument operation more efficient. So I'll talk about a few of those as we go through the talk. I did want to touch on one thing, and I'm not going to go into detail on these science themes. This is our in-house science program. So we not only work with users, but we have an in-house science program that we like to engage our users in some way so that they can tell us the types of tools, the types of capabilities, techniques, methods that they would be interested in seeing. And if they fit within some of these science themes, then we can work on those topics outside of a user project. So we have quite a few users that are involved in our in-house science. And what results from this primarily, other than publications, are new capabilities. We have new capabilities for synthesis. We have new capabilities for understanding quantum materials. We have new capabilities for direct write, for in situ microscopy. All these different things are typically developed as part of our in-house science program. And that takes up about half of our budget for the year. So we're not just there to work on standard problems. We like your input, and we like to drive some of our in-house science based on the needs of the community. So I did want to point that out, that that's a very strong component of the CNMS. Forgot that this was like that. So our CNMS capabilities right now are primarily focused in 4 areas. Imaging, again, is one of our strongest suites of capabilities that we have, ranging from a high-end electron microscope that you see pictured here. This is our max stem. I'll talk a little about that later, but also down to scanning tunneling microscopes, scanning probe microscopes, any number of different types of scanning probe microscopies that you can think of that measure different things that could really provide insight into materials problems. Very strong theory and simulation group, the Nanomaterials Theory Institute, that is integrated with much of what we do. We have precision synthesis in both organic and inorganic materials, and we have our nano architectures focus that is done in the clean room. So it's a very comprehensive suite. You don't have to just choose one thing. You can use any number of different things for the research that you need to do. You can access any of these capabilities in a single proposal. So you don't have to write a proposal for each and every tool. It's all accessible once you have a proposal in place, whether it's proprietary or non-proprietary. Alex mentioned that we're open for business. We are open for business. We are doing a majority of our work right now via remote access, so we haven't shut down. Our staff is still coming in. We may not be entertaining visitors at this time, but we are working and we are doing user work. So we do everything via remote access, remote operation, if somebody is an expert in that area. We're hoping that by the summer that we may be able to start allowing people to come on and be trained again like we used to operate. But right now, this is the mode of operation, but it really hasn't hindered us. It took us a while to get up to speed, but we're moving pretty smoothly via this remote access mode of operation right now. So the next couple of slides are really lists, and I'm not going to go through every tool on here, obviously, but I did want to let you see the scope of the types of capabilities that we have. This presentation is going to be put on our website. So if you have a question about any of these capabilities, what they can do, what they might add to the science that you're doing, I suggest that you go on and look up all the gory details of what you can get out of these techniques. If you look at our scanning probe suite of instruments, for instance, we have any number of different types of scanning probes that provide different kinds of information. And if you're interested in electrochemistry, if you're interested in very low temperature scanning tunneling microscopy, if you're a metallurgy company that wants to do atomic segregation to grain boundaries, you may want to access our atom probe tomography capabilities. And I'll be honest with you, that's a very popular facility for many of our industrial partners. We have more industrial people who come to use atom probe than probably just about anything else. So rather than me going through everything, this is a good opportunity just to quickly go through a couple of slides and show you the extensive array of capabilities that we actually have at the CNMS. We also have these capabilities for we call it bottom-up synthesis, where we're actually moving atoms. We're nanofabricating materials from the single atom to the types of nano architectures that you see on the right. We have capabilities to do that in the electron microscopes by moving atoms around. This is very important for quantum materials right now. We also have all of our normal capabilities in a clean room for creating nano architectures or creating new materials, focused ion beam, e-beam lithography, nano patterning. We have a nanoscribe. So these are all very important tools that we can use to help our users devise new nanostructures. Precision synthesis. One of our strongest groups is really our polymer synthesis group, because they do things that a lot of other polymer groups don't do. They synthesize new macromolecules, for instance, and they also are our strongest bridge to the neutron scattering facility, because we can selectively deuterate materials to understand the structure of polymers. So we are very strong in that area, and we're also building capabilities now. We just hired a we call them governor's chairs, a leader in polymer synthesis, who is establishing a 3D printing or 3D manufacturing capabilities at the CNMS for 3D printing of polymer materials and making the specific feedstocks, the materials to go into these 3D printers. So very, very strong capabilities for people who are working in the polymer area, polymer industry. But we also have very nice capabilities for making very interesting inorganic materials, thin films. We have pulse laser deposition, we have CVD, we have all kinds of different synthesis capabilities available for making any number of different materials, some of which are labeled here. So, and importantly, I want to emphasize again that one of our another strong group is the Nanomaterials Theory Institute, that we take full advantage of the computational platforms that are available across ORNL to not only do theory and simulations, but to integrate these into our tools so that we can then integrate strong methods for doing data analysis, feedback, create these feedback loops to progress some of the operations of our instruments towards full autonomous operation. A lot of this new work that we're doing is to enhance our ability to efficiently do experiments. If we can, add or take time away from doing some of these long-term experiments by integrating AI/ML into that, then we'll be able to serve more users. We'll be able to do this in a much more efficient way. So that's one aspect of it. The other is predicting materials. We have quite a nice effort in PLD to integrate algorithms that can then help us design or accelerate the design of new materials. That's a very impressive facility, to say the least. So we're very excited about all these new opportunities and the way that we can work across ORNL to take advantage of all these advanced capabilities. Do want to highlight a couple of new instruments that we've recently invested in. So this is mostly for quantum materials, understanding quantum phenomena at the single atom level, really. So we've invested in all these tools that you see here. We haven't received our spin polarized STM yet, but it has the capability to go down to 30 millikelvin. It's going to be a very nice capability, the first in the US. Same with our monochromated aberration corrected stem. It's one of only 2 in the US, so we're really excited about some of these capabilities for advancing not only synthesis, but understanding materials behavior, understanding materials structure, and being able to then use that information to design new materials. So the CNMS is here. It's not just, so I say addressing the nanoscience mission need, but it's broader than that. We look at bulk materials, structural materials, we look at biomaterials. So there's quite a breadth to what we actually do. The capabilities are there, they're unique, they're cutting edge, many of which you won't find anywhere else. And we want to, again, encourage you to look into these capabilities and see if they can help you fundamentally understand questions that may come up in material synthesis, materials performance, devices, any number of different things. And our staff is here to help you identify if any of our capabilities can help you along the way. So another thing I want to emphasize is that we are co-located with other facilities, and it's easy once you are, I'll say, in, once you have an active proposal to actually access a lot of capabilities across the laboratory, neutron scattering, for instance, or high performance computing. These are all capabilities that are run out of DOE by the same user facilities division. So we make it easy in that regard to take advantage of all these capabilities that we have available. We do take your input seriously. If they're, that's what our in-house science is for. We listen to our user community, we listen to industry. If there's things that we don't have or things that we can work on within our in-house science, then we will try and accommodate the needs that may be out there that we actually may not have in-house. So with that, I'll take any questions. And I want to point out that we will actually be hosting a large industrial workshop in the fall so that we can, again, enhance our interactions with not only the CNMS, but the other user facilities that are at Oak Ridge National Laboratory. We don't have a date yet, and we don't know whether it's going to be virtual or on site, but it will be in the fall of 2021, and we'll keep you informed. So if there's any questions, I think, are we saving questions for the end, Brad?
Yes, let's go ahead and save the questions for the end. So you can go ahead and type your questions now in the chat or the Q&A box if you have them, and then we'll try to answer as many as possible at the end.
Okay, thank you very much. I'll go ahead and unshare my screen.
Okay. All right, I'm transitioning over right now to get my screen live. I'm not sure if it's, all right, there we go. So I want to talk a little bit about the user proposal process at CNMS, or how you would gain access to the CNMS. And this will be a two-part presentation. When I'm finished talking about the user proposals, Jennifer Carpenter from our from ORNL Strategic Partnerships and Agreements will talk about user agreements. So the first thing I want to highlight is the CNMS website. This is where you can find more information about a lot of the capabilities that Karen discussed. You can see the web address at the top of the slide. You can also just Google Center for Nanophase Material Sciences and it will come up. And if you click through the headings or the drop-down menus, you can find information about the CNMS, including the link to a virtual tour of the CNMS. And there's also a video under the user program overview that highlights a lot of what Karen talked about. The specific capabilities at the CNMS are under this capabilities drop down. They are listed, are associated with the different groups here. You can just click through those and there'll be a full list of the capabilities that are available to request through the proposal process. And then here, find more information how to access CNMS, the different proposal types, the tips on writing and submitting a proposal, and the review criteria, which I will also cover in a few slides. And then lastly, we really encourage you to contact us. If you are interested in writing and submitting a proposal or learning about more about a capability, it is important to try to contact the CNMS staff and get information with them. They will help you, will walk you through the proposal process, give you feedback on the feasibility of your proposed research. And so if you're not sure who to contact, you can just email Karen or myself, and we will put you in contact, or actually Ilya or Alex, and we will get you in contact with the correct CNMS staff member. So again, please go to the website, have a look around, learn more about the capabilities. When you're ready to submit a proposal, we have an online proposal submission process. There's a link on our website to get to the portal, or also you can go directly to cnmsproposal.ornl.gov. If you've never been here before, you will need to create an account, and this will take you to the ORNL guest portal where you'll register. And once you've registered in the guest portal, you can not only access the CNMS proposal system, but you also have access to the proposal system to submit a user proposal for neutron scattering. Here is the proposal, online proposal system. Once you're signed in, you again have links to the CNMS website as well as the specific capabilities at the CNMS. And down at the bottom is the button to create a proposal. Once you select create a proposal, it brings you to the next screen, which again has some submission guidelines. And it also talks about or shows you the different, so the first step would be selecting the type of proposal you are going to submit. So the most common is our general proposal. So we have 2 proposal calls a year in the fall and the spring. We have one that will is open currently. It closes May 1st, and then we'll have a second call, which will close in October. We also have a rapid access proposal. Those are for projects that are much shorter in duration, typically less than 5 days of time, and are for time-sensitive measurements or proof of concept. And then again, we have our proprietary proposals that Karen mentions, which do require a full cost recovery. You can also see on this proposal page that you can just work your way across the tabs across the top. So we have general information, participants who will be participating from your team on the project. There's a tab for the facilities, samples and hazards. So that is where we'll have a drop-down list of all the capabilities at the CNMS, and you'll go through and select the capabilities that you're interested in using, and then also the number of days that you're requesting for each of those facilities. And then if you look to the far right, we have a tab for research description. So this is probably the most important part of the proposal. So there are 6 questions that are asked in this description of proposed research. And so you can see the list of the 6 questions on the slide, and the percentage after the questions is how those are weighted in the review process. And so the first question is, what is the main scientific or technological question that you plan to address? And that is worth 25% of your review score. I won't read through all of the questions. These are also posted on our website, but just to show you the list of the questions and how they're weighted here on the slide. And once you have submitted your proposal and the proposal call closes, these projects go out for external review, external scientific review. And I'll show you that the reviewers are going to be scoring your proposal or are evaluating your proposal based exactly on the questions, those 6 questions we presented, I showed you in the previous slide. So here are the first 4 questions. Question 4 is actually split up into 4A and 4B, but you can see that they're judging or evaluating each of these questions on a 10-point scale. Here are the second 4 through 6, the questions, and then you will get a total score based out of 100. Once the scientific reviews come back to the CNMS, they are evaluated at the CNMS based on your scientific score, as well as the availability of the resources for the specific capabilities that were requested. And then notifications are sent out to the principal investigators, and research, the research projects can then start. And you will have a technical contact for your project, and you are to coordinate with them the work on your project and how it progresses. So that covers the proposal process at the CNMS and how you can find out more information. Again, please contact us if you have any specific questions. And at this point, I'm going to go ahead and transition this to the user agreement overview. So Jennifer, if you're ready, you can just go ahead and start talking, and I'll change the slides. Oh, you were muted. Let me back you out real quick.
Okay, sorry about that.
Nope, you're good.
Okay, do I have control of the slides or do you?
I'll keep changing them.
Okay, why don't you go ahead and move it to the second page?
Sorry, it started over.
Oh, okay.
Here we go.
Okay, you can go ahead and move to the first page. This is really a recap of a lot of what Karen had said, but the Department of Energy has actually put a lot of thought into how they run these user facilities and how they allow access to it. And as Karen had said, what they found over the years is that the facilities can often are needed to get very good results. They need to work together. And DOE wanted us to be as flexible and as responsive as we could be out to the science community. So what they have done, unlike a lot of the other DOE programs, is they tried to standardize the agreement side of this so that people were not getting slowed down with agreements and contracts and lawyers and stuff like that. So DOE has set up blanket agreements, and that blanket agreement, you sign it one time, and it allows you access to all the user facilities at a specific site. So once you have one non-proprietary agreement at ORNL, then you now have access to CNMS, SNS, all the other designated user facilities. And that does allow that flexibility that Karen was talking about, that you may come in on a CNMS project, and as you're going along, you may realize you might need some other resources as well. And this way we don't have to stop the project, go back through, relook at legal language, because it's the same agreement. You're operating under the same terms. Unfortunately, part of that does mean these are non-negotiable, but I find that when we explain the rationale for that, then the users, they understand it and they do appreciate it. They appreciate that responsiveness that we are able to allow, because we don't have to go back in and open up an agreement when there's some scope change or when you want to grow something. And so like I said, it sounds harsh when we first say it, especially to the attorneys, but it really does work very well. And it does allow us to be very responsive. As Karen mentioned, in order to be flexible, DOE had said, okay, we can foresee a time when not only do we need non-proprietary access, but we also, businesses, once they saw all the use that quite frankly, the universities were getting, they said, hey, we'd like some of that. That could help us as well. And that's why DOE did grow the program to allow both proprietary and non-proprietary access, and to again have that sort of a standard approach for both scenarios. The one thing that is unique at the end of each project that we host, DOE does request that we have a releasable report. Obviously, no one is going to ask you to report anything that is in any way business sensitive, that is being patented, anything like that. So I say a report, because if you work with your facility, these reports are not always, don't have too much detail to them. But DOE does want to know what people are doing at their facilities. Okay, next slide, please. Can we, ready to go? Okay. Can we go to the next slide, Brad?
There we go.
Okay, thanks. So the non-proprietary projects, as Karen mentioned, that's really the bulk of what we see at most of the user facilities at the lab. And just for point of reference, we have over 2,000 active user agreements right now. So what you may find out is your company or your university may already have one of these agreements in place. So it really is just a matter of applying for time at the facility. As Karen also mentioned, these projects are free. Basically, DOE is covering our portion of the cost of that project. And in the end, the return is good science is now put out into the environment. And also DOE, quite frankly, gets a little bit of advertising for their resources, and we get more involvement with other researchers. As Karen said, the facility benefits, DOE benefits, the users benefit. It's really a good collaboration. Okay, DOE does not cover the user's time. So when you travel to the site, you are going to have to cover that. But really everything else we take care of. The results from the project must remain releasable. We cannot market as proprietary data. If that is the case, again, we need to just get you into the proprietary projects. We can handle it, we just can't do it under a non-proprietary agreement. I bring that up because we have some users that come here and they're paying their portion of their costs with another federal award. We've got lots of researchers that come in, they've been granted, they have an NIH grant or an NSF grant, and we want to work with them. Just, we cannot contradict what your funding agency is saying. So really, we have to work in the non-proprietary space if you're receiving a federal award, and that's why you're coming to us. And if anybody wants to talk about that in detail, I'm happy to. It's a little complicated, but I bring that up so that you're aware of it. There's language in the non-proprietary agreement that actually cites, if you're coming to us under a federal grant, the terms of your grant actually will control. So it's very nice. It's a well thought out detail. Okay, next slide, please. Now the proprietary projects, this is, as Karen was mentioning, we don't have as many, but we are starting to see more interest especially from industry coming in. DOE does require full cost recovery for that, but the benefit to you paying the full cost recovery is then you can mark your data proprietary and you will own the inventions that come out. As Kara said, it greatly reduces what, if anything, that we can discuss, talk about, release. And there are some businesses that's a concern to. There's also some businesses who say we really like free, and we can work with, the data may be so detailed they don't feel like it would be advantageous to their competitors to put it out there. I've heard that they don't expect anyone to even understand the data, so they're okay with it. But really work with Brad, Ilya, and Alex. They'll figure out where you need to be. So my next slide, which I think is the final one, if you have specific agreement questions, please feel free to reach out to me or Courtney Hennard. She's our group leader, and we will be happy to answer any language questions that you have. But I would strongly encourage you to go through Alex, Ilya, or Brad. We all work very closely together to try to figure out if an agreement is even needed, if, because we have 2,500, so we have a lot of people already under agreement, and how we would facilitate your access. So please go through them because they can answer much more specific questions. I can just answer language questions. So that's really all I have. If there's any questions, or Brad, if you want to tie it back to something else.
Yep. Thank you, Jennifer. I just want to conclude the presentations and just, what would the next steps be? Obviously, we're going to stay around for a question and answer, but please visit the CNMS website to learn more about the capabilities. Reach out to us or other CNMS staff to discuss those capabilities and submitting a proposal. And just want to let everybody know that we do have a general proposal call with a deadline coming up on May 1st. And so with that, I'm going to hand it back over to Alex.
All right. Oh, I think I'm live now. Excellent. Well, I think that concludes our presentation. Please stick around or write to us. You've seen, like Karen has said, all the information that you may need to get started is at the CNMS website. Brad, myself, and Ilya would be your point of contacts. You, of course, are welcome to write directly to either Jennifer or Karen, but I think we would be able to help you a little bit more precisely as far as what type of agreement you might need, just so you can get exactly the answer you're looking for. I think with that, we thank you for your attention, and unless there are any questions, we'll see you soon.